Okay, so number two, notice what they're saying. Angle W is congruent to angle V. So let's put that like angle W right here and angle V. They're the same. Like, I don't know what it is. Maybe this is 30 degrees and this is 30. I'm just making it up. I don't know. But they're telling me they're congruent. And then they say T is the midpoint of WV. Ah. So if you go from W all the way to V, the midpoint is right here. That's the middle of WV. T is the middle of WV. What does that mean if T is the middle of WV? Well, that means this side must be the same as that side, huh? Like maybe this is 10 and that is 10. I have no idea. Whatever they are, they're the same because that's what it means to be in the middle. If you're in the middle of something, then the two halves are the same. Okay, great. Is that enough information right now? Do we have enough information to prove these triangles, these two triangles are identical in every way? We don't have enough yet, do
No.
we? We need a third piece of information. Does anybody see something else that we know? Like, remember from our last unit one? Why do we know those angles also have to be the same? Why?
Because
What kind
they're
of angles are those?
aren't they corresponding angles?
They're
They're
diagonal to each other,
actually,
yeah.
yeah, they're diagonal. The official word was called vertical. I'm not going to quiz you on the word. But yeah, remember we learned that diagonal angles always have to be equal. Whenever you make an X pattern, those angles or the ones top and bottom also, either one, the ones diagonally across from each other, whenever you have an X pattern, the ones diagonally across from each other have to be equal. So, that's just diagonal angles are always equal. Okay, so now do we have enough information to prove that those two triangles are identical? We actually do. So again, I don't know what those angles are. Maybe this is, maybe this is 70 degrees and 70 degrees or whatever, who knows? But yeah, we have enough now, don't we? Why? Because we have an angle, a side in between, and another angle. See how in both triangles, same thing here, angle, side, angle, huh? We have two angles and the side in between. Two angles and the side in between. So yeah, we can say the two triangles are congruent by angle, side, angle. Again, let me come back down to this for just a second. So this is from the exam, two notes. Triangle congruence, angle, side, angle. Remember, any three-letter combo will work. Any three-letter combo is all you need. You don't need to know all three sides and all three angles. Any three-letter combo works, except not the AAA and not the bad word ASS, forward or backwards, right? All other three-letter combos is enough information to prove that two triangles are identical, congruent. So yeah, angle, side, angle is enough. So they are identical. Now, here's a tricky part. Let me come on down here. We need to make a statement. This is usually the hardest part for people, is making this statement down here the congruent statement. Let me write it here a little bigger. So we need to say that triangle STW is congruent. The equals with a squiggle at the top means congruent, identical, to triangle. And so now how do we say the other triangle? Well, we have to order. The order is very important. The order is important, very important. You have to get the order right. Meaning, so first off, what's triangle STW? What's this one? STW. So this is triangle STW. It's the one on the right. We're saying the triangle on the right is congruent to the triangle on the left. But how do we say the triangle on the left? We've got to say it very carefully, very precisely in just the right order. So how do we say this triangle over here? Well, you got to go piece by piece just right. S is the same, S, which is right here, which is the piece that sticks out in the triangle on the right. That's the same as which point or angle in the other triangle. So the triangle over here, this triangle over here, the one on the left, this triangle S in the triangle on the right is the same as which point or angle in the triangle on the left. Can you tell which one it's the same as? Yeah. Yeah, Nelsie's got it right. It's the same as U. Yeah, Martin's got it right. You see that it's the same as U right there? See how those guys are the same? Yeah, so this has got to go, we've got to put U here. S and U correspond to each other, don't they? They match up. S is the one, it's not the 70, it's not the 30. Same way U is not the 30, not the 70, it's the other one. It's the one that sticks out. S and U are the same part of their triangles, aren't they? The ones that stick out. Okay, what comes next? T, which is right here. T is the same as T. T is T in both triangles, right? T is right in the middle. It's a piece of both triangles, so obviously it goes with itself. And then finally, what's left? W, what is W? W right here. W in the triangle on the right matches up with V, V in the triangle on the left. And you can tell because it's a 30-degree angle and this is a 30-degree angle. And so there we go. That order is very important. You've got to put it in just the right order. In other words, you cannot say triangle VTU. That's not right. You got to say UTV. So right here, you got to say UTV. Why do you have to do that? Well, because when you make a congruence statement, you're saying the two triangles are identical, and you're saying S matches with U, T with T, and W with V. The order matters. You're saying which sides or which angles or which points probably is best, which points go with which points in the two different triangles. So there's the order we must follow. Questions on that one? Is that making sense?
I have a question.
Yeah.
If a letter is the midpoint, will that letter always be in the middle of the order?
Yeah, it will. Well, oh no, I'm sorry. It'll correspond with itself, but they don't have to say it in the middle. Great question. Let me mention that. Yeah, what if they originally, let me change the problem. What if originally they had said, because you can say a triangle, the first one, in any order you want. It's just once you do the first one, you have to follow the same matchup for the second one. That's a great question, Eddie. Let me address it. Yeah, so I didn't even think about it. It's a great question. So what if they had said triangle TSW? They could have for the first one. So you can say the first one any order you want. If you can put the 3 points down in any order you want, but then when you're saying it's identical to the second triangle, you have to match up the right points with the right points. So if they started with T, I'd have to do T first because T always has to go with T. And then if they did S next, I would have to do U next because S and U go to the, and if they did W third, I would have to do V third because W always has to, W is the same role. He plays the same role in his triangle as V does in his triangle. Great question. Or what if they had instead, I'll say, or what if the original statement, they can make the original statement any order they want. What if they had done, I don't know, WST like that? They could have put the T at the back. Again, you can do anything you want with the first statement, but then once you make the first statement, the second statement must correspond. The same points must line up with the same points. So W, he's got to line up with V. He'd have to come first with V because W goes wherever V is. See how W matches with V wherever he is? Right here, I had them both at the back. Right here, I had them both at the back. Here, I have them both in the front. Whatever, they've got to go together. And then S always matches with U. Oops, back that up. S always matches with U because they play the same roles in their triangles. So I'd have to put U next, S with U, and then T always goes with himself because he's the same angle as himself. He's diagonal angles. He's 70 degrees and 70 degrees. Yeah, good question. So however they started the first one, they can start the first one in all kinds of different ways. It doesn't matter. But once they do it, we've got to make sure the order on the second one matches up. Whenever you make a statement that two triangles are identical, you've got to make sure the right points match the order of the right points. Great question.